All right, so we are going to practice a little bit of statistical process control using the uh, Math for Manufacturing workbook that was put out by Ray Prendergast from up at Daly Center Colleges up in Chicago. This is a good resource material that he created quite a few years ago. He's since retired, and I wish him well in his retirement. But this is a great workbook that he kind of put together that has gotten a lot of attention, and so we're going to kind of go through that. Now, it is I do strongly recommend you kind of read the beginning of this so you understand a little bit more about it, but we're going to kind of go down, and again, he gives a break-by-break synopsis down here as well. But we're going to go here to worksheet 10-1, and we're going to kind of use this to learn how to actually do these type of calculations. All right, so here we have problem 1. We're given a caliper measurement of the overall length where the print dimension shows 1.275, and we're given plus or minus 10 thousandths as far as the tolerance on that. So then the operator or whoever was machining this, we've got these dimensions that have came out: 1.277, 1.267, 1.271, so on. You can read those off as well. So the first thing that we're going to do here is determine X. Now, I'm going to kind of write this down. This would be easier to do, of course, on pen and paper, but since I'm here in my house kind of creating this for you at the moment, we're just going to kind of type this out in a Word document so that you can get a better idea. But you can do the same thing in paper. So as we note the actual formula here, so we're going to say X equals here, and then remember that the Greek letter epsilon here is referring to the sum. So the sum of all of the X, where X is our data set. So we're going to say that's going to be 1.277. So we'll use the plus 1.267 plus 1.271 plus 1.265 plus 1.279 plus 1.284 plus 1.276 plus 1.286 plus 1.281 plus 1.282. All right, so there is all of those added together. Now, in your calculator, you know we have to add all of these together before we actually would divide them up. So and I can sit here and say, all right, well, I'm going to have a parentheses here and a parentheses over there. That makes sure that those will all be added up first, and then we're going to divide that. So we can kind of put the division sign here, and we're going to divide that by the number of the total number of data in our set. So let's see, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to divide that by 10. All right, so let's go ahead and now X equals then. So as we kind of go through this, so let me pull up my calculator. So let's kind of clear out the calculator here, and let's see what's going. So we're going back to this 1.277 plus 1.267 plus 1.271 plus 0.265 plus 1.279 plus 1.284 plus 1.276 plus 1.286 plus 1.281 plus 1.282, and then I can say enter here to equal. So I see that this is equal to 12.768, which I still need to divide by 10. So we'll go ahead then now and X equals here. So let's go ahead and divide this by 10. And my mean is 1.2768. So there's the answer for my mean. So, all right, now the next part is to kind of figure out and get both the median and the mode. So as far as this type of idea here, so we're going to go back forward now, and we're going to kind of change things around. So we're going to go high to low here. So as I take a look at this, I could start out with the lowest number that I have, which looks to be like 1.265. So I'm going to go ahead and we're going to copy this here, and I'm going to paste it for right now. So Control V with the exclamation point, and just to make sure that we know and understand that I've already got that taken care of, I'm just going to underline that real quick so that I know that I've gotten that one in there. All right. The next one here looks like as I come through, we're at 1.267. So I'll go 1.267. I'll go ahead and enter these in, and I'm going to underline this one here as well to make sure that I know that I've got that. It doesn't matter. I'm just kind of doing this. You can bold however you need to in order to figure out to make sure that you've got what you need. So the next highest or biggest number after 1.267, I see 271, 281. So it looks like 1.271 is going to be the next one here. So let's go ahead and go 1.271. So, I made that italics. Let's go back and I didn't want that one italics. I wanted it underlined. All right. Next is going to be from, so I got 1.277, but over right here I got 1.276 first. So let's go ahead and underline that. So 1.276. After that, then comes the 1.277. All right, so 1.277. So all I'm doing here is rearranging these numbers from high to low. So 1.277 looks like 1.279 is next. The hardest thing I think for some of this is just keeping track of and making sure that you don't actually miss any of the numbers in the data set. So as you go, so all right, next highest number is the 1.281. So let's go ahead and enter that, 1.281. Then I see right next to that is the 1.282. So let's go ahead and underline that one. 1.284 and 1.286 are my two last. So I can sit here and say, all right, next is 1.284 and 1.286. Just to make sure that I'm not leaving anything out, I'll get these underlined too. So all right, we know that we had 10 up there. Let's go back and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So I've got the 10 there as well. So I'm now to take a look at the median. So all we're doing right here is we're saying, all right, we're coming in. What's the one that's in between the two? So I got 1, 2, 3, 4, 5. So, and because we are have a even number of data set or data inputs here, we're going to have to take the average of these two and average those together. So as we see with both of these, let's just go ahead and so we keep a track of those. I'm going to bold those, and we're going to have to come down here and say, all right, so the median here equals parentheses 1.277 plus 1.279. We'll go ahead and close the parentheses off and divide that by 2. So when we calculate this out, so we realize that the median then will equal to 1.278. So and the median here is 1.278. Now, Lastly, let's talk about what the mode is there. So again, as we sit there and say the mode, so we'll come back and see how much or what is the repetition here with mode. So I'm going to just kind of bring these numbers back in here. So let's kind of keep these together. So I'm going to copy these and paste them in so that we can see this real quick. Let's go ahead and paste. So Control V. All right. And at this case, I'm going to undo here. Now, the mode is the number that would be represented the most. So if you sit here and think about it, do I have any mode or any of these values that occur more than once? Well, in this particular data set, as you can see, as I look through, there is no number that repeats itself more than once. Now that would be kind of rare. It is going to be, in our measuring, as we increase the number of amounts of actual component parts that we're checking, you are going to get a reoccurrence of these different numbers. All right, so you're going to ask yourself, since none of these repeat themselves, then what is the mode, or how do we refer to it? Well, we just say that there is no mode with that particular data set. So that gives you an idea here of how to actually do these problems. So we've kind of done the first one here together. I'm going to give you some time now. You go ahead and here is your micrometer measurements of an outside diameter. You need to find the mean and the median, and we'll go ahead and make sure that you also find the mode, if there is a mode on that one there as well, to finish this off. One thing that I want to point out here, so notice in this case right here, when we determine the median, so I still have that as a 4-place decimal. So notice we were 3-place decimals with all of our data here, so that should indeed be a 4-place decimal in terms of our actually calculating out the mean. So down here with this data set, so all of these particular measurements are 4 decimal places, so that means your mean should be what? So what should the mean, and how many decimal points would be carried over when you calculate your mean? I'm going to let you think about that. Go ahead and get this done, and we will come back with the next video in this particular lesson.